Alrighty, well, happy Thursday. Let me go get logged here into Canvas. So, slightly behind, but we got slightly ahead last week. So I think it's all going to work out and it'll be okay. Let's grab this here. All right. So we were going to do Unix Tuesday. We started doing objects and classes early because I wanted to do Unix Tuesday. So we'll talk about Unix today, and then we'll finish up last little bit of objects and classes. I think we're pretty good still. We're pretty good. So when we use Unix, it's a whole fun operating system that has nothing to click on. It's all based on typing in black boxes, which all of our programs we've typed in black boxes, and that's very exciting. But now imagine that's the entire way to interact with the computer. So there's a couple tools we can use. So from Windows, to connect to the Unix system, you can use this PuTTY tool. If you're on Macland, you can use your terminal program. And you can actually do that on Windows as well, too. So I like that better than PuTTY. I just think it's more fun, and it's built in now. So with the Windows terminal program, we can connect in as well. So we're going to use the SSH protocol. I think that's what that is. I think it's a protocol. Yeah, secure shell. So cryptographically secure way to connect to remote network things. I'm a terrible network person, so but it's a way we can connect in. So we're going to log into the school Unix server. So it's login.umd.umich.edu, and it says, okay, let's log in here. Now, this is not my account here, so this is not going to work very well because I didn't tell it what my username was. So it tried to pick up the username from my computer, and it got kind of confused. So I'm just going to cancel out there. So I need to tell it which user. So if I type in SSH and then a dash question mark, I get help. The dash question mark, or sometimes dash question mark, is a pretty common way to get help at these command line prompts here. So to tell it what I want to log in with, I need to give it -L for my login name. Here, super exciting. So I'll do SSH, or if I hit up, like it'll go back to my commands. That's pretty common. So again, less typing, lots of shortcuts here. So say -L, and I give it echarnes for my username here. Now I should be able to go and log in here. And when you type in this password box, it doesn't actually look like you're typing, which is the weirdest thing here, but you are typing. So probably a security thing. And then this is all linked into Duo, which is nice. So it should do my two-factor authentication. Yay, it beeped. Okay, that's a good sign. This chair is not great. All right, and now I get my home prompt for Unix. So this is echarnes at login. This little tilde character here, which is the shift of the accent right above your tab key, means you're at your home folder. Now, again, this is all we get in Unix land, is just a black box prompt here. So there's a bunch of commands that you don't need to memorize. There's a cheat sheet for it, or just Google Unix commands, those sorts of things here. If you use them a lot, they kind of stick in your head. And so that's what it is. So if you want to see what's in this folder, right? This idea, your home location is just a folder, right? Everything is folders and files. We just don't get pictures to click on now. So if you want to see what's there, you can type in ls for list, and it'll show you, hey, there's some stuff here. I got a bunch of stuff mapped to this location here. Now, there's some things here that probably I didn't put here with Unix. What's cool is if you log into the college computers, it connects you to this thing which looks like a drive. They call it the H drive. When we log in through Unix, we have access to everything on our H drive. So they're connected. It's kind of cool. So I've got some folders here. I've got a public folder. I've got a private folder. I've got files here, right? PY files for Python. I've got PDFs from a long time ago. I've not cleaned this drive out ever because I only do this like twice a year. I never need to bother with it. So I do have a folder for CIS 200. Right? A fun thing, if you have the public folder here, so if you wanted to change or move to another folder, you use the CD command for change directory. Super exciting. So CD, and then I can type in public. And if I give it a couple letters and hit tab, just like if we're typing in our IDE, it'll autocomplete here. Now I'm in my public directory. So if I list this one here, I've got this HTML folder. So I'm going to go into HTML, and if I go here, I have an index file, which is kind of fun. So if you want to see the contents of a file, you can use the cat command. I don't actually know what that's short for. I don't know why, but you can do that, and it'll spit it out to the screen here. This little HTML file. Turns out this stuff here is hosted on your personal page. UMD personal? Here it is. So because I've got that file in my H drive on the Unix server, the college actually serves it up as a personal web page, which is just a fun fact. So it's this personal UMD umich.edu. Some people have like some serious ones here, like Dr. Zoo has an actual page here that doesn't look like Mario font and fun links, but it's my website and it entertains me, so I get to do that. So you can have stuff hosted there, which is fun. But that's all connected in. So that's that folder. If you want to go back a directory, right, there's no like up button to click, so it's CD space ... means up a folder. CD space ... Now we're back to my main drive here, which is very exciting. Okay, so I'm going to change into the CIS 200 folder here. And I've got, oh look, I already have a CPP file. Very exciting. I think I've done this before a few times. If you want to edit the text here, we don't have a lot of options. So there are some good editors and there are some bad editors, and then there's Vim. People love it. Most people hate it because it's awful. But if you get good at using it, it's not so bad, like any sort of tool here. So if you want to edit something, we can say VI. This is our I don't know what that's short for. Hang on, what is Vim? What is Vim? VI. Come on, what does it mean? Text editor program. What is it short for? I don't even know. Do you see it? It's not important, sorry. Anyway, so we can use VI to open files. So I can either open a brand new file, or I can open an existing file, like the Hello World Unix CPP file. Now we get the Vim editor. Vim is all sorts of special because the fine folks who use it know in Unix land you don't really use a mouse ever because there's nothing to click on, right? Everything is based on typing. So to move around and to do things, you have two modes essentially. You have command mode, where you give it commands that make it do something, and then you have edit mode, where you're actually typing. And you can flip between the two. So to move around here a little bit, you have most shortcuts are based on the home row. So the J and K key, notice the cursor, it's a little hard to see here, is going up and down when I do J and K. I don't know if you can see the cursor going up and down there. So you can navigate up and down lines without taking your hands off the home row of the keyboard. Because obviously, if your hands are on the home row of the keyboard, you can type the fastest. And we're all about typing fast here. So very fun stuff. If you just want to go Google, Vim shortcuts, probably your best bet here. Look at this, the shortcut cheat sheet. There's actually a really cute mug that I almost ordered that has like all the different Vim commands on it. It's like a wraparound mug, and I thought it'd be really funny. Except I only use it twice a year. And having a mug that I only use twice a year would not make my wife very happy to have to keep it around the house. So you can navigate different places very quickly here. And actually, it's very powerful if you get used to it here. So if you want to jump forward 5 words, you would type 5W. Sure. If you want to go back 5 words, 5B for back. Right? You can move to the beginning of the file or the end of the file with G or GG. And again, the idea is here, your hands are almost always on home row. Right? You can go to the beginning of the line, you can go to the end of the line, first non-empty. So all sorts of fun shortcuts. We don't need most of these things, but escape goes into command mode. So if we're typing and we hit escape, it'll take us to command mode. Then we can give it all sorts, so to get into insert mode, right? So insert for us, so we can type and edit files. when you're in command mode, to quit here, it's not even in the shortcut list here. It's going to be down here somewhere. Here we go. :W will write the file. Save. We think of it as saving, it's writing the file. So that's why it's a W. I think so. :Q will quit here. If the file's been changed, it tells you, hey, you probably don't want to quit now, because you probably want to save your work first. It's helpful. If you really, really want to quit, oh my goodness, these ads are awful, :Q, exclamation point. Force it quit here, or go in :W and then :Q. And this is why there's whole jokes you might have seen before around people not knowing how to quit Vim once they opened it. Because you have to hit escape to get back to command mode, and then you have to do :Q, and if that doesn't work, you have to go save your file. And none of this should be in your head, because it's silly. But you can, right? So here's my file. Looks awesome, like CPP code, C++ code, right? Typed out by hand with no type ahead suggestions, which is really sad, that nothing types for me and I can't hit tab anywhere. This is not fun, but you can do it, right? So if we want to go change it here, let's go down here. We'll go now I hit I and it goes to insert. You see kind of down here at the bottom left, the insert mode. So now I can start typing here, or I can arrow around. So we'll say hello world from snowy Unix land, right? Now, if I want to save my file, I have to go back to command mode. So I'm going to hit escape. The insert thing goes away. Do :W to write my file. That says, hey, it wrote the file. It was written. Then I can do :Q to quit. Okay? Now we got that. Now I want to build and compile this file. In Visual Studio, we just hit the little run button and it does it all for us, and then actually runs the executable. For us to do that, I don't even remember how to do it. So I did post the lab assignment here when I finally woke up. I don't expect anyone to have done it here because I didn't really say anything about it. But it's here, and we've got a little cheat sheet here with the lab assignment. This one we're not going to turn anything on GitHub, and I'm sad, but that's okay. We're just going to do screenshots in this. It'll be the only time ever, but it's in Unix anyway. So to make our file, we're going to use a couple commands here. Let's see. We want the, oh my goodness, where did it go? GPP. I don't know why it's G, but G, and then the name of your CPP file. And then you can either get an a.out file by default, or you can tell it the name of the executable you'd like it to output with -O. Again, don't memorize this, please. It's not worth your time, right? Just have fun. So G++, the name of our file here, it's hello world Unix. Again, the tab will type ahead for me here. -O, and then we'll say please work. And then when I list here, I have this thing called please work. And if I type in please, and why is that not doing the please work? /please work. There we go. To run executables, you can't just give it the name here because that'd be too easy. So I have to say dot, which is my current folder. So dot is up a folder, right? It's the current folder and then up a folder. Someone came up with this a long time ago here, and we just have to live with it now. So /please work here, and now enter, and I get the output of our program. We've now written a program, edited a program in Vim, in Unix. We compiled it in Unix, and we ran it in Unix. You're all super excited. You look at me like I'm crazy. It's okay. Now the cool thing, though, is if you're doing big processing stuff, working with lots of data, sometimes our little tiny laptops here aren't the fastest. So being able to do all sorts of intensive processing on someone else's computer is a good thing, right? Farm off all the work to someone else's computer where it can spin and sit and do all the cycles here while we play games on our computer while we wait or do something else interesting, right? It's not that the cloud stuff isn't cool, but before we had like the quote, what we know as the quote cloud, I'm a really old person, I have to say the word quotes, I'm sorry. We all know the cloud is just someone else's computer, we could use SSH or terminal to use someone else's computer, but instead of it being the cloud, it would be in a data center somewhere or on campus somewhere. Like there'd be a computer we could connect to and run these things. The cloud thing now just gives us computers with clicks of a button. You say, hey, I want a computer to run a bunch of stuff, and Amazon says, here you go. Or Microsoft says, here you go. Or Oracle does cloud stuff now. IBM does cloud stuff now. Like it's a bunch of nonsense here. So cloud market share. I mean, it's interesting that they go do this, but sure. Where is it here? I think I want the chart. Is this the good chart? Yeah. So, yeah, sure, we'll take the cookies. Have you seen the Cookie Monster cookie meme? Oh, that one's so good. Cookie Monster. Accept cookies. Comic. No, where is it here? It's images. Hang on. This is totally worth our time here. Where'd it go here? I can't find it right now. You fool. Cookie Monster. You fool. Cookies. All right, it's not in here right here. Oh, it's got to be one of these ones. Delete cookies. All right, anyway. Cloud share. So AWS does the bulk of the cloud. I thought 32 is low. That's interesting, whatever they say here. So sure. So 30% of cloud services, right? Someone else's computer is done by AWS, Amazon. They make lots of money off this. Microsoft has invested tons of money to be a player in this space and actually has some cool stuff for Azure, the Azure cloud. Google has some cloud stuff. Some people like it. Sure, they'll do a bunch of compute. Alibaba's up and coming now for the non-US market. Trying to eat into some of that here. IBM Cloud, I don't know anyone who uses it. They give it away because they want people to use it, please. So there was like a whole training thing. They were like emailed out like, hey, come use our cloud, please. And it was just really sad because no one wants the IBM Cloud. Oracle has a cloud. Tencent has a cloud. Salesforce has a cloud. So anyway, cloud services are just someone else's computer that the idea is you click a button and it starts up and you can connect to it, which is cool, right? This idea of the college Unix server, it just sits here and it's always on, right? There's no, I want to turn it on and connect to it. It's just always here for us, right? So I wouldn't really call this a cloud service because it's probably a physical server somewhere on the campus somewhere. I don't know if it's on this campus or if it's actually at Ann Arbor. It doesn't really matter where it is, right? We just connect to it. So from home or not on the campus Wi-Fi, you have to use the VPN, and then you can get to it. Okay, if you're on the campus Wi-Fi, you don't need the VPN, which is pretty nice, right? It gets you on the college's network. Our virtual private network VPN. Sometimes I just say words and assume you all know what it means. Okay, that was a good one. VPN's okay. All right, I don't know sometimes. Like, I don't know. You're all tired looking because I'm tired this morning. Yeah.
Would you be able to show us how to get on the VPN or if we were to access it?
Not. It doesn't work from here. But you just search the instructions. Dearborn VPN. There's a quick guide here for it. It'll take you through setting it up. And then you can go and connect in. It's pretty quick. Again, the stuff we're doing, we don't need any of this processing power. We don't need to offload anything. We're not doing anything big. But it's fun to be like, hey, I can run my C++ programs on Unix or farm stuff out there and do those sorts of things. Yeah. And one of the things you agree to is you will not mine Bitcoin on the college Unix server. It's in one of those agreements you click on when you log in somewhere. Don't go do that. Someone will probably notice that your account is using lots of processing power, and then they'll wonder what's happening. Right, and we don't want to contribute to that waste of electricity anyway, which is so weird. What a weird way to develop a thing. Anyway, so this is the Unix lab. This is what we were going to do Tuesday. And little change of plans. It's okay. It doesn't take long but typing all the commands to do all these things is a little tedious here, right? So there's like 5 things we're gonna do. Just log in is one of them, right? If you can get logged in, you've done step 1. That's great. This pwd command, your print working directory, super exciting. It tells you what folder you're in. Now it's kind of fun. Like you can go up a folder and up a folder, and now I'm in the home E folder. So if I list here, these are all the people with E usernames. It's a lot of E's. I would have thought there'd be less E's. Now, Unix has its own set of file permissions, so if I wanted to go like check one of these out here, like ESW, that looks fun. So if I go to ESW, it says permission denied. I can see that it's there, but I can't get into the folder, right? So you can have a very fine level of permissions detail. Turns out you can do this with Windows networking as well, with networked drives and things like that. Works very similar, but then you have buttons to click on in Windows land. So, but it's fun, you can see it all there. So I'll go back to, if I just do CD and the tilde character, it'll take me right to my home drive. I don't have to remember what my username is or type stuff here. That's my nice little shortcut. Or if I'm in other folders, do I have another one here? Yes, CD, backup. Okay, so I've got a backup. So I can just go back to my home drive anytime I want. Just CD and the tilde character, and it takes you back. So fun stuff with Unix. Right, so getting logged in is one. Making your program is another. Now, you can transfer it. There's a WinSCP tool for Windows, secure copy. I don't even know what this one is. So I've used this one before and I have it installed. This is how I keep my website up to date. I transfer files over. I do it on my computer and I just transfer here. This gives you a fun little drag and drop interface, which is cool. Unix.edu. Then we can get logged in here. And this gives you 2 folders. Let me get logged in here. You see the left-hand side is your Unix drive, and you see the right-hand side is Windows. So I can get the things from my computer. Sorry. It's weird. All right. So if I want, this is my home, I'm sorry, the right side is my Unix drive, the left side is Windows here. So I can see, here's my website, and I can go actually like click and drag and drop things like that. And say, hey, do you want to update it here? It's the exact same file because it's not been updated. So you can write your code in Visual Studio and drag and drop it over to your Unix account, right? You don't have to write them in VI. Please don't. We're going to do it once for fun, but you can like use an actual editor and then transfer them over here for fun. So that's task 2. Task 3 is moving files around. If you want to move files around, you can use the mv command or move. Again, we got some shortcuts down there. We can show you how. Then this is making directories. You can make folders with the mkdir command. So if I see what's here, I can mkdir like example. And now when I list again, I get a, where'd it go? There it is, the blue example. Yeah. And then if you want, you can move things into this example folder, see what's around in here. There's nothing in it right now because it's empty. But you can make folders as well, right? Yep, awesome. So that's what we're going to work on, right? Didn't we do, one of these was VI, I thought. Yeah, so task 3 has you making your VI command here and printing things. So that's what we're going to work on next Tuesday. If you want to do it early, have some fun, and we've got time. We're going to do a little bit of the other stuff as well, though. So we have to double up just a little bit here. There's not too much more. That one's relatively quick for that lab. We want to talk a little bit more about objects and classes. Might get to exceptions and pointers. I don't think we'll get to too much of that for the lab. I think we can probably stick with Unix and then do some more classes work for that. Okay? All right. We're feeling okay? That was just silly and fun. But we're going to show you can do stuff in Unix, and then we can check it off our accreditation box that, yes, you've used more than one operating system, and everyone's happy. Okay. It is really cool. I make lots of jokes about Unix, but being able to use the terminal and do stuff on other computers is really cool in the real world, right? Just for our use case, it feels really silly and forced, because it is silly and forced. That's all. All right, so let me pull up Visual Studio here, take a look at our zyBooks. 50. This one? No, not fall. Goodness. Let's go back here. I want to make sure we're getting everything out of that chapter. So we talked about constructors. Oh, unit testing, right? We hadn't got to unit testing yet, right? I think that's about where we left off. We're still in week 1 classes, right? Yeah, so we're working with chairs. Okay. Now, chairs were all fine, well and good. We have our default constructor, we have our parameterized constructor. Whatever we should be doing with our code, we can write the code for it, right? If you should be able to make default ones and then go set all these values later, go for it. If once you make a chair and you can't change those things, don't give them a default constructor with a bunch of set methods, right? You don't have to have public set methods. So we got rid of this set color one. We're just pretending here that you can't go take some paint here and change the color. So if once this color value is set, you can't change it, we need to have then the parameterized constructor that lets you set the color and not give you a default one, because then you could never have a color of your chair, right, if you take the default one. Or maybe we make this one black. Right? You've got some choices here. So that all depends on what should be happening based on what our code does for us. Right? What are we trying to model in the real world for this? Okay. So the get height, or I'm sorry, the set height, we had some sanity checking here, right? We said, hey, let's make sure that you can't have a negative height. Now, for us to test this, right, and make sure that it does what it was supposed to do, we didn't actually try that yet in our code, right? So if I were to ask you to test and make sure that it worked, I'm guessing most of you would just come into your console here and try it. We'll say, hey, Eric's chair dot set height in meters to like -5, and then we can print the chair details for Eric's chair, and we're going to look at the screen and make sure we don't see a -5. Is that what we do for testing? Right? It's reasonable. That's the only thing we've done so far. Right, and we see, hey, now my height is 0. It's not -5. My code probably works. Okay. Now, a couple problems with this. Right. One, if you've ever written an English paper and had typos in it, and when you read it, you didn't see those typos, does that happen to you? Right? You have the word was in there twice, or you double up these things, or spell things wrong. I mean, spell check's pretty easy nowadays, and even the double words for grammar checks are easy, but we make typos all the time because we're bad at it, because we know what we expect. So having to print stuff out and then look at it on the screen is failable, right? We're not going to catch everything, right? And this is a little slow and tedious here. And then every time I go change my program, I have to run it again and make sure I didn't break it. Now, we're probably not changing set and height in meters very often here. It's not like we have to test this every time we change our chair class. But it's nice to test to make sure that things work as expected. So you know who's better at saying, I expect it to be a 0, please look and see if it's actually a 0 than people? You know who's really good at that? And who's the wrong word, sorry. What's really good at that? Computers. Computers are really good at that. They will catch it because they said it should be a 0, check and see if it's 0, and they don't get bored, they don't get tired of running it, right? They're not going to, I've been coding for 4 hours, I keep hitting run, and then you missed that the output doesn't work. Computer won't do that for us. So we can use unit tests, and we can make the computer check it for us. You all should be much more excited. I get that it's really early in the morning and it's snowy here, but making the computer do that work for us is great. And that's sort of what we're learning in our entire degree program, is how we make the computer do work for us, right? It's sort of the goal here. So we're going to write code that makes the computer test our code, which is fun because we like writing code. I mean, hopefully you like writing code. If you don't like writing code, you got the wrong major, because you're in for a lot of writing code for a long time, right? Okay, that's supposed to be exciting, not depressing. But okay, so we want to test it. Now, this is one of the reasons why I like having the inline functions here. It makes my testing easier. There's ways to do your testing without all the inline functions, but life is just easier when you have them inline for now. Right? It's not the right way, and we'll just We'll accept that. This is the quick and easy way for us. Later on, when we care about speed and we have large projects and you hit this compile button and you've got 50 or like 5,000 different classes, yes, we want it to be fast. Right? Fast is good when you have 5,000 of something. We have one of something. I don't really care if it's 3 times slower. Not going to affect us here. But for testing here, now everything we've done so far has been one project in one solution. One in one, right? But the reason why we have solutions is you can have more than one project in a solution. So I'm going to come over to my solution here. I'm going to say, hey, I want to add a new project. And in here, make sure I've got the right language picked here. I'm going to search for test. Now we've got tests here. The native unit test projects here work great in Windows land. You've got some other test options that'll work on other languages, but not here with C++ right now. There's, what can you use here in XUnit? Or, oh my goodness, Xcode, unit testing framework. There's something you can use here. XC test? Yeah, so if you're using Xcode, there's a different thing you can use because you're not using Visual Studio anyway. So there's ways to do this in Xcode. I don't own a Mac. The college won't buy one for me, which is probably silly that I ask them all the time. But I'm like, hey, my students have Macs. Will you buy one for me? They're like, no. But maybe you could put that in the end of the semester evaluations that they should buy Eric a Mac so I can help you Mac folks better, right? That might work. Anyway, so you've got options, but we're going to do the Windows way here because we're using Visual Studio because that's what I have here. So the native unit test project here, and I'm just going to leave it called unit test 1 because I don't really care. This is fine. So now I have 2 projects here. I have the unit test project and I have my week 1 classes project. The unit test project has a bunch of stuff here that we just got, which is cool. It's the Microsoft Visual Studio CPP unit test framework. That's the namespace that we're using. So a lot of these things come from this namespace, like test class and test method. Wow, those are, sure, they're big, but it's fine. So this is where we're going to write code that tests our code. And what's super cool about this is if you have a separate project for test code, if I want to give someone my program here, when I build this program, it will exclude all of the test code. So this idea of giving someone a deliverable, giving someone working software, which is sort of the goal eventually, right? That you will write interesting software that is cool enough that someone else will want to run instead of just you running it and me running it. Right? It'll be worth someone else's time to run it. All of the test stuff doesn't have to be in here. So right now, if I were to say, hey, you have to turn in your chair project, but make sure it all works, you'd probably come in here and comment it all out or have to go delete it all and then do the things I said to do with chair, right? Like, hey, your assignment is you have to make these 3 chairs, make one for me, make a big chair that's a very hard surface for the dad bear, make a big chair with a very soft surface for the mom bear, and then make a small chair with the just right surface, firmness here for baby bear. So it's the Goldilocks story. My kids watch Sesame Street all the time, so that's all I got in my head right now. But we can keep all the test code separate from the code you actually give someone, which is great. So it makes things smaller and more efficient. And most of the time, you don't want them to have your tests, right? They probably don't, but keep everything behind the curtain sort of thing. So to test our code now, we need to go include our other file. Now, we've got it in a CPP file. This is not great here. So we're actually going to move chair. Okay? So I'm going to take everything that we did in chair here. I think we need string as well. So I'm going to take chair, and I think I can do this. Can we do a refactor? Extract, not as a function. Move definition? No, that was wrong. Wow. No, I'm just going to undo that. I'm just going to cut here. And I'll come back here. I'm going to add a header file. So I'm going to add a new, this is going to be a header file. We'll call this one chair. Here. And I can put my chair class here. Right? And again, I'm using string, so I'm going to include string here. Again, this is why the using namespace standard gets to be a little weird, because we start including other files. It gets to be a little bit messy. But standard is easy for us. I don't really care. Now to use chair here, right, we would include, this is stuff we did in 150? Okay, good. We're going to include chair, chair.h. And include, when you give it other files, remember, it's essentially you're telling the compiler to copy paste. Take everything that's there and just jam it in on top. Pretend it's one big file when we actually do our compiling process. And this is why having H files and separate CPP implementation files speeds things up. We don't really care about the speed up piece here again, so that's great. So I'm going to include my chair file. So everything I want to do for my assignment, I can go and do here. I can have my print chair details. I can make all the different chairs. Now in my test code, I'm going to do that same thing. I'm going to include that file, but it's not here. It doesn't show up as chair because it's not in this folder. So it turns out that same ... thing is useful here. I can say ... says go up a folder. Right? When we make our solutions, if I view this in my file explorer here, the solution is week 1 classes, and there's a project for week 1 classes, and there's a project for unit test. So from the unit test code, I have to go up a folder, and then into the week 1 classes folder to find my chair H file. So they include ... to go up a folder, and then go into the week 1 classes. Week 1 classes, come on, I want the type ahead. There we go. And I want chair.h. Chair.h. Right, so up a folder, .dot is up a folder. Right, into the other project folder, grab the H file. Probably, I don't think it matters here, but I'm going to give it the capital here. Now I can use chairs. So when we write unit tests, we're going to follow this AAA convention here. It's just a style, just a way of doing tests here. It's not required. I'm quite fond of it, and lots of developers are quite fond of it here. And if we follow conventions, it makes life easier for everyone. Visual Studio doesn't care. C++ doesn't care how we do it here, but everyone else who does it and knows to expect this sort of thing will be really confused if you don't do it. Right? You want to make life easy for everyone. So this AAA convention is we're going to arrange, and then we're going to act, and then we're going to assert. So for arrange, we're going to set up the variables we need to test. Act is we're going to call the code we're testing. And then assert is, did we get what we expect? Right? So to test a chair, if I expect certain things to happen when I call set chair height, right? I'm going to have a ending chair height or an expected chair height. So for a double, for my expected chair height, we'll say is like 2.5. So when I'm done with my set chair height method, my function, it should land at 2.5. There's a valid value. It should work here for us, right? So this is our test, and kind of you want to rename these things. This is set chair height. Having good names here, I'll show you, is useful in just a minute. So you can actually distinguish what's happening here instead of test 1, test 2, test 3, test 4. Just like you shouldn't have your variables A, B, C, D, E, because those are terrible variable names. You need to have good method names now too, good function names too. All right, so the expected chair height. That's the variable we need for us to test. Then we need a chair to test with. So I need a chair for chair. Okay. We can use the no argument constructor, or we can use the parameterized constructor. Either one's going to be fine. I'm just going to go, what I really care about is testing the set height in meters. So it doesn't matter what it starts with. I don't care about the color, right? I don't care if it has wheels or not. All I care about right now is if setting the height works. So to call the code now that we're going to test, we're going to say chair.set height in meters, and I'm going to try and set it to the expected chair height. So this is the code we're testing to see if this works. Now, to know what the new value is, I need to go and ask the chair class, what's the new value? So I'll have a double for the actual chair height. Chair height. Now, if you we probably should be saying in meters, right? Because that's the right thing to do here. So chair.get height in meters. Right, and chair height in meters. We can be obnoxious about this and add in meters everywhere, right? So set it and then go get the value right away. Because that's the only way I know to see, did it actually work? What is the value here? And then we can assert, did we get what we expect? So we can say assert colon r equal. There's a bunch of these things in the assert library, assert class here, right? This is from that CPP unit test framework. That's that namespace we included. Okay, so assert colon gives me a bunch of options. You've got r equals, probably a pretty common one here, but you can say, is it true? Is it false? Is it null? These sorts of things here. So r equal, and we give it the expected value. So my expected chair height and the actual chair height. Are those two things equal? Now this is code I can go and run, right? I can right click here and I can run my tests. Where's my run? No, sorry, not the right click there. I can go to the test section here and I want to go to Test Explorer. In Test Explorer, it says, hey, you need to go and click Run All. Okay, let's click Run All. It will go discover all my tests. And I can see in here, it's a bunch of the unit test project, unit test class, because I never renamed these things, right? But I see my test method set chair height. And I see a green check mark here. It passed. Green check marks are happy. We like when tests pass, right? So if I didn't give it that, if I said, hey, is it 2? Does that match the actual 2.5? Sorry. There we go. It needs 2 doubles. It was confused. Not 2.5, 2.1. There we go. We want it to fail here. And now I go to my Test Explorer and run my tests here. We're going to fail. And what's cool with the Test Explorer, it will tell you exactly what went wrong here. It says, hey, it expected 2.1. It actually got 2.5. Because when you call a R equal, the first thing is what you expect. The second thing is the actual value. So I can quickly see, hey, thought I was going to get a 2.1. Something went wrong here. I got a 2.5. Right? The computer's doing that looking. I don't have to spit it out on the screen. I don't have to see out it and then use my eyeballs and look at it and say, hey, is it 2.5? Okay, yes, my code worked here or not, right? Now, that's the expected. Now, this one's not super exciting here, but again, now I'm gonna copy paste this here, and this is the set chair height negative. Stops at 0. You can make these things as long as you want here. Remember, the name of it shows up here when it passes or fails. So having a nice name here will help someone understand what you were testing without even having to look at your code, right? That's the goal. If you have the nice name of a function, you know what it does without having to go look at it, right? It's like, what should work out for us? So if I set it to a negative, I will expect it to be 0 here. If I set it to like negative 20 here, I should get 0 and 0. Right? So I'm just going to change a couple things here. So it's a little bit wordy to do this AAA convention thing, to set everything up, but you just copy paste most of the time for our tests. It's not the worst thing in the world. Okay, so let's give that one a run. And now I have the run test. So once I've done it once, now I have my options for run tests when I right click. I'm not crazy. There we go. And we'll see. Did this one fail? Shouldn't have failed. Didn't I run? Run tests. Okay, now it passed. I think it just didn't actually run here. So now it passed here for us. And we see that the testing for negative worked as well. So I can write code that does all these tests for me. Does it feel like a lot of extra work? Yeah, it is a bit of extra work here. One of the cool things we can do now is once we have code that runs these tests, we can do the next step. So, and this is the unit testing level. That's the smallest level. I want to test one small unit, essentially one function at a time. We're testing. There's larger tests. You can get into integration testing and system testing and end-to-end testing and all sorts of other fun things like that. We're just looking one small unit at a time. But what we can do once we have unit tests is we can plug this in to our source control tool. And we can say, hey, when code changes, go run the tests. So anytime any code changes in my project, I can make someone else's computer in the cloud run all the tests to find out if something broke or not, which is really cool. So, we're lazy people. You probably ran the tests locally here, but some of these test suites take a long time. If you've got 50,000 projects here, and you've got 50,000 tests for all those different projects, that's going to take a little while on your computer to run. You're probably not going to do that. You probably ran the tests for the code that you were playing with. Hey, my job was to go and add a feature for share. So I did the chair tests. Well, maybe that broke something else that used chair downstream or somewhere else. This sort of idea. So if we can have all those tests and run them automatically, you can see like on Microsoft's VS Code, anytime there's a commit here, you can see the tests that ran. So 13 out of 17, 17 out of 17 passed. Oh, some of the tests failed, right? It's built into these source control tools. We know to go run tests. There's fun things you can do. So it looks like, hey, this one failed after 61 minutes. Had test failures. This one failed for the Mac OS build. I don't know what these ones are, but you can go look at them here, right? The Linux unit tests passed. This took 7 minutes. you probably don't want your developers that you're paying lots of money to sit there and look at their computer for 7 minutes and run a bunch of tests, right? Probably not worth spending a lot of money on, right? So if they can make another computer do it, and they can go keep doing other things while the tests are running, life is good. Right? We're making people more productive. So you can build all of these tests into and automate the tests so that when your code changes, it's called continuous integration testing. As code is integrated, we run our tests, which is great. So we have a good feel. So these tests are still currently running, right? They committed this 9 minutes ago. We're done with 5 out of the 8 tests so far, right? So every time code changes, we can run some tests. And we build out this library of tests, and we keep the library, it's like ever growing, so that when I'm working in my code, because most of the time my code lives, in this maintenance phase where we're updating and keeping it, adding new features or changing things here. It's not the full-on we're starting from scratch. We're just tweaking things or adding new features as we go, right? We make sure that everything still works. We don't break anything, so all the expected behavior can be codified and put into code. Hey, this should happen when I do this, and make sure it keeps happening here. We don't add new bugs by changing other things. So we can write tests to do that, which is super fun. Depending on your product here or what you're working on, the next thing we would do is continuous deployment. So if you have a high level of confidence that if all of your tests run, your software works, you can then move on to the step of let's now go deploy the software and go make it live. I've got friends who now work at Khan Academy I used to work with. The Khan Academy website is updated dozens of times a day, right, with their development team. They have got this process where if all the tests pass, it will automatically update the live website, which is super cool. So as their developers are working, they can take something from whatever phase they're working on. This was the idea, the concept, or whatever their task was, and get it out into the production place where users use it very quickly. That makes developers more efficient, right? Depending on where you work, right, the amount of time that it takes to get a software update to my insulin pump here is really, really, really long, because I get emails from these people like, hey, please go update your pump software. And I just don't care to sit down and take the time to do it because, I don't know, it's not doing it automatically for me and it works okay. And then they're like, Eric, you have to update your pump, which I probably should go and do at some point. But, your operating system, Windows has gotten very good about, hey, please go update, please go update, please go update. You're updating now. Good news. Which upsets some people, but this is a good thing, right? It's very risky for us to have old, unpatched operating systems out there. Right, that was the problem years ago with their older operating systems, that you could just delay the updates and say, no, I don't want to do it now, I don't want to do it now. And then software would get out there from people who have nothing better to do with their lives than to ruin things ruin good things for good people. And we'd have essentially botnets. So all the unpatched Windows XP devices that got malware installed on them now serve as botnets for people because we were too lazy to patch our computers. Right? So Microsoft said, hey, we probably don't want to have millions of devices out there that serve as a botnet for people. Right? So we'll make you patch. Good news. It's very exciting. So if you can continuously deploy your software, it makes things faster for you. Right? In general, for businesses, faster is better. Right? You want to decrease the amount of time it takes you to get a change into users' hands and find out if it's good, bad, or ugly. Right? You folks use Spotify? Spotify updates a lot, right? Now it's not, a continuous deployment here, because you probably don't want to have to go update and download an update for Spotify 5 times a day, but they have a similar kind of process where all of their tests will run. There's a really cool video here. What is it? Spotify engineering culture video. It's worth some time here. Point.
Monday.com.
Oh goodness! Wow, that was loud. Sorry. I just want to skip the ads. I just want to see how long it is. Yeah, so this is 13 minutes. This one's not too long here. This kind of talks about what they do here and how that works. So I'll post that later in the Discord. This is a fun video. But same idea. They want all of their updates to get to their users quickly to find out, is this a good thing or a bad thing? And then they can do all their fun stuff. Other software engineering things we'll learn about doing like A/B testing. So half the users get this version, half the users get this version, and we see which one people like better, or which one gets more clicks, or which one makes us more money. It's sort of what it all boils down to, right? So if I give half the user the button and it's in green, I give half the users the button in blue, which button gets clicked on more often? All sorts of silly little experiment things you can do if you can get your code out faster, unless you turn stuff around like that. So having a good suite of tests is useful for that sort of thing, which is great. All right, so those are tests. Comparisons, operators, this, namespaces. We didn't talk much about static. We can come back to static. I know we're just about out of time here. So static values mean they exist at the class level, not the instance level. So with chair, I make instances of chair, and we're going to have 30 different chairs in memory, each with its own color, each with its own height, each with its own value for set wheels, or has wheels. Right? Static things exist with the class definition. So I might have something like, hey, chair number or serial number, and that has a single value there. And I can go and update that as new chairs are made. I can go and update the serial number, and each chair can get like a serial number stamp. You can do some fun things with it as static. So they don't show up as our regular attributes. Where is it in here? So to call it static, you add the static keyword. Right? Yeah, the IDs for things, right? This is the store ID. So it belongs to the class level, right? Not the instance level is the big difference. Yeah.
Didn't we define the attributes for chair in the class?
Yeah, so our chair class has private attributes for color, height, and has wheels. So every instance of chair has these three values stored in memory somewhere, distinctly separate from each other.
So then I'm still confused on what exactly is the difference between that and a static.
So if I have a static int like ID here, the static ID is only defined one place. So if I make 50 chairs, I don't have 50 different IDs. There's only one value for ID out there. Well, you might use that value, and like each chair now can have a serial number that is the current ID. And as I make chairs, it will just kind of pull that next one and the next one and the next one and the next one. There's lots of things you can do with static values. We don't get into too much of that. Depending on what it is, we sort of frown on static values. It makes object-oriented programming a little bit more awkward. Sometimes they're great for certain use cases. Most of the time we say, hey, if it's an attribute of a class, every instance of that class should have that attribute, right? It should have its own value, because that's why we write our classes, so I can have distinct sets of these values around, right? So we'll look at, and probably do another example next week of when static might be fun. Most of the time we're going to try and avoid it. That's all. All right, so it's testing and Unix. Next Tuesday we'll come back. We can move on to, see, I think we're doing all right. We'll talk exceptions and pointers. We can do the lab. We'll do the Unix lab, a little bit on classes, double up a little bit there. I want to might do exceptions. We'll see how far we get for the lab exercise, and we go from there, okay? All right, stay warm, and good luck on the roads. It was super slow, so that'll be fun.